Okay, we're going to move along here. Thank you, Sharif and Matt, for that. And we have, I'll just put a little pitch in here for COVESA. We have an opportunity for what we call charter and core member level members to give thought leadership sessions during our COVESA all-member meetings. And what you just experienced was one of those, and what you're going to experience now with Gerald from Bosch is another one of those. But it's something that we, sort of a member benefit at our two top tiers of membership, to be able to do a thought leadership session at one or both of our all-member meetings, depending on the level that you're at. And so, just if you're thinking about what level you want to be at, and when you're joining, then just think about the opportunity to have the floor for a thought leadership time at our all-member meetings, and based on the level, you can have that opportunity going forward. So now it's my pleasure to introduce Gerald Spreitz. Gerald is a great friend of Geneva and COVESA. He's been around a long time with us. He has served faithfully on the board of directors for many years. He's not that old, but he's been around a long time.
Yes.
And he's served in many different roles. He's been a treasurer, he's been a secretary, he's now the vice president of the board of directors, and he is the director of the open source office of cross-domain computing at Robert Bosch. And this is a unique opportunity for COVESA as an open organization to have somebody placed in an open source office in such a large company as Bosch. So he's a tremendous asset to our organization. So welcome him to the stage.
Yeah, thank you, Steve.
Yeah,
thank you for the introduction. So I think we're a little bit delayed, but that's the normal food chain, yeah? The OM is delayed and the tier 1 has to run faster. Okay, good morning, everybody. I hope you all enjoyed the day yesterday and the beautiful reception and the beautiful terrace. And Steve asked, what has changed? And I had the same question, but not what has changed since last autumn in Dearborn, but changed here and the way of living. And I remember that I was here before in 1985 doing some backpacking after school, and it was a great experience. But at that time, they had border control still, so no EU travel free. So you were in the train the night, the doors open, light on, passports. So that was a different time. There changed a lot. And also way of living changed. So yesterday was the Freedom Day here in Portugal, so the anniversary of the revolution in the 70s. And yeah, even in 85 the life was different. Also this area, so this impressive bridge was there, this 2-layer thing. I still be impressed of the architecture, and the caves were there, but not that fancy. So today we have a lot of fancy bars and restaurants. So the way of living changed. More tourists, everyone walking around, and yeah. And technology changed. So people have their phones and they live in digital ecosystems. They are integrated. But not only people, so also our vehicles are integrated in digital ecosystems today. And that's what my talk is about today. How do we realize the integration in the ecosystems? I had the impression I will repeat a lot of aspects Steve and Sharif had before. That's not because we aligned on it. So I have different slides and different words, but the aspects are similar or the same because it's the time now that this thing has to happen in the industry. So I think we are aligned in these ideas. Yeah, so I will take you on which slide I have? The first one. I would like to take you on a journey which started already a long time ago. So at COVESA times, we start to integrate open source technologies, but already some of the digital ecosystem aspects were integrated. The connectivity came up. in the first phase in the vehicle infotainment area, but then we broadened the focus to the connected vehicle. And step by step, this led also to the foundation of COVESA. And in the first phase, it was more to connect the driver. But what we have to do is to connect the vehicle. So people talk about often what the intention of the driver, what the driver is doing, but we also know vehicles getting more autonomous, so we have to integrate the vehicle and detect the vehicle's plans and wishes and how the vehicle reacts to situations. And what we need for that is a harmonized interface to the vehicle. And that's the focus of COVESA, the focus of Bosch and the industry, and the focus of COVESA. So let's have a little bit of deeper look there. So this slide you have, well, this picture you have seen several times already, I believe. And also my colleague Achim explained in much better detail than I will do yesterday. So we see the evolution of the electrical and electronic architecture of the vehicles. So we came from a situation where we had one box for one function. And step by step, these boxes were consolidated in domain controllers. These domain controllers realized several functions in a specific domain, so in body or infotainment or engine control or brakes. And were decoupled from sensors and actors. And this went forward so that we consolidate domain controllers in vehicle computers. And again, the controlling logic is more separated from sensors and actors. And in future, not so far future, we also will have the operation of the car partly controlled from the cloud. So I'm not talking only about sending data to the cloud, but really controlling the operation of the car. And this leads to a vertical stack here from the deeply embedded area over several layers to a cloud application, which is cross OEM, cross brand, cross fleets, and covering the whole community of vehicles. And there we have several layers of interfaces to realize this. And I'm sure that we need an harmonization of these interfaces, not overall, but we agreed at least one or two layers which should be aligned in the industry to realize the new functionality. So here in the embedded layer, we have messages and physical signals and of the sensors which are connected to the hardware. And then we have a lot of hardware abstraction. So this is already state of technology that we can abstract the different hardware modules with their individual interfaces to a more common representation of sensors. And we can also abstract this in virtualization, and we are operating a system as abstraction layers and so on. But still, the behavior on the functions of the vehicle are specific. So we have still vehicle-specific representation on these levels. And what we should go for is a harmonization southbound of the application layer, so that we can more easily develop the applications against this interface. And here comes also Matt and Sharif talked about the update cycles. And here on the application layer, we will see the greatest impact of this harmonization. So when we still talk about years to change protocols on buses or some changing hardware modules, this is years and months, and even more software-oriented things, we need still weeks to update them and validate them. But here on the application level, we can gain with an harmonized interface. And that's what VSS is about. We will model the vehicle and agree on the semantics of the individual data points so that applications and the vehicles understand each other. So this is the important point. But let's have a little bit deeper look here. Does it work? Right button. So we will have onboard applications which are installed in the car. We'll have offboard applications and a mixture of that, a combined things. So do you perceive any need or value in having different off and onboard semantics of the same data and functions? I do not. So what we should have is one API for onboard and offboard solutions and applications. We're convinced that in future most mobility features will be cross-domain, covering body and engine control and infotainment. So do you think it makes sense to build domain-specific APIs? I don't. So we should have one API which covers cross-domain the whole vehicle. We're convinced that in future a lot of obligatory features will be cross-ORM, cross-fleets, cross-cities or other entities. So does it make specific APIs? No. We should have an API which covers brands and fleets. We will likely start in the QM area, but that's not enough. We need safety-relevant applications to really enable user experience we want to have. There are several talks here on the conference which gives you more details on these aspects also. So we believe we should have an API which covers QM qualified applications, but also safety ones, likely with additional tooling and additional measures. So this API should have a broad scope. And when we talk about connected functions, we also talk about data, but we also about functions. And we believe that this is an integrated solution. We need a signal-to-service API. And I thought a little bit how to explain it, and then I came to just this easy equation, which is hopefully not too complicated for a business track. So you will get access to data via this API and this tree, and you will have access to functions in the vehicle. This is a little bit future-looking, so we need a lot of work to do, also here in COVESA, to enable it, but that is what you need. And the combination of both is then the signal-to-service API. So, to explain a little bit this wording. A lot of theory, let's talk a little bit of an example. Low friction. This is a dangerous situation which might occur on the streets because of wet or roads or icy or other substances on the road. And it would be very helpful to have a near real-time method to warn other drivers or other vehicles, which are autonomous, for this dangerous situation. But there's no authority you can realize this, so we need a community approach to realize it. Today's vehicles are able to estimate the friction value in their ESP system. And for a community approach, we must take this value and translate it in a harmonized way that is defined what this number means. And this is the semantic of the value. Then we can combine this data with metadata like precision and time and so on, and upload it over the stack over the OEMs portal to a service provider. And this service provider can generate an overview of the situations and generates a map, a friction map, nearly real time, and then warn other drivers in the area about this situation. So this is just one example how an harmonization in the semantic will enable a function and a community approach which is interoperable and brings a real and useful user experience. Other example, maintenance, vehicle health. Also, Ford people talked about this. So of course, this data will help to detect problems in the car, and from that you can prepare your repair methods and so on. But in the future, based maybe on some AI solutions, the system will already detect problems before they really hit the availability of the car. So we'll do some predictive diagnosis, and then you have a little bit head time to organize the repairs, or the service will do it for you. And this will in total reduce downtime and costs of the maintenance, and reduce the downtime of your car and your vehicle. So there's also big value inside with this. These are two examples how this whole system could work and be beneficial for you. Now I want to highlight one aspect we haven't talked so much before. That is the access rights management. So when we harmonize things and open the vehicles for third-party applications, it doesn't mean that everyone can just access everything and do what he wants. So we need to control it. So you own your car and drive around. There's the manufacturer who still has lots of responsibility for the safety of this car, so you rely on that. And there will be service providers. And this service provider can develop an application, maybe the friction warning I explained before, or whatever it might be. And he will put in the credentials to his service, to the application. And what we suggest is that this application should have a wish list, which signals are necessary in which behavior. This application is then transferred to the OEM or other trusted entity to be validated, and there the OEM can add another key for the values, for the data signals, which are where the application is allowed to have access. Then we have the driver wish and consent, of course, which is important. And we have all this. The application could be installed in the system, in the car, and the connectivity will be enabled to really get access to the signal and services. With this method, we have controlling over who has access and who is able to doing what. So I'm not talking about just infotainment apps, yeah? So that will be maybe easier. I'm talking about real vehicle operation apps, yeah? Which might have safety implications. And here we have to be a little bit careful who is allowed to do what. And yeah, so this is just one aspect. There are several other aspects, legal aspects, who is responsible for what, billing comes on top, who is paying for what. A lot of questions to be solved, but that's maybe for the next talk then. Break. Doing some advertising. How do we develop in such a scenario? So we need good ideas for applications and we have to test them. So you need quick feedback and user experience testing of if your idea is valid to be driven further. For that, we have set up the digital.auto project, which is completely open. You can just go there and realize a simulation of your application, program it against the VSS specification, and test the user behavior and the user interface. There are already a lot of example applications available. You can also learn on this conference about this. For example, in the EV charging project, they're using this playground to simulate these things. So these apps are based on the COVESA VSS specification and allow fast feedback and testing. Also today on the showcase, you will have their examples how you can explore the possibilities of that. Okay. Summary. So, I think the Ford people had this different picture, but the same idea. So we have a lot of vehicle platforms which also needs their own integration and validation effort. And each platform ends up with specific software even for similar features. This is a pain today. So we have to change this. And we need an open API which is harmonized about all platforms and many OEMs. And we need collaboration on an open standard instead of proprietary APIs. And this will decrease the software prices. And this open API should be suitable also for safety and real-time applications. And this will cover, let's say, the compute hardware from the overlaying applications layer. Vehicle API should be one thing which works cross-domain, cross-brands, fleets, which covers on- and off-board and cloud applications and integrates data and services. So that's our call. An open harmonized interface is a must in the automobile industry, and that's what COVESA is about. And please join here the efforts and the working groups and bring in your ideas. And that helps us keeping vehicles moving. Thank you for your attention. Maybe, I'm not sure if we have time for questions. Nat? I have a couple. Okay, maybe the third and the fourth?
Thank you. So basically you talked about the unified API. Yeah?
Yes.
On which level
Yes.
you envision it
Yes.
to take place? Some kind of IDL with different language bindings or something else?
So the starting point is the vehicle signal specification. This is not an API. This is semantic, which models the car. So this is the important thing. And then on top of that, we will have likely different transmission protocols, how to access this data. And this is not yet fixed how this is look like, and likely we'll have different ones. So could be VISS, could be in the Autocar Corporation, we will likely look for something useful, hopefully not something new, but something what exists already. And that's what we should, and then we need more tooling, yeah. But we are open to realize these things together.
Okay, fine, thank you. And the other one is philosophical and not directed actually particularly to you or your company, but to everybody else.
Okay.
So I heard a lot of mentioning open source and then safety, certification. Yeah. How do you think that with the current state of ISO 26262, whatever, and open source can be mixed together into something usable? Because, please correct me if I'm wrong, but I deeply believe that you won't be able to certify anything coming from open source methodologies if there is no paradigm shift in safety community.
Yeah, this is a difficult question. And there are examples of safety from the train tech area where they developed something in open source, but you have to develop according to the safety rules in the complete open. What is difficult to certify existing open source code to the safety area. And when you do that, you will lose the ability to the open source brings with a fast update cycle. So that are the problems, of course.
Yeah.
And there are different ways to tackle that. Also, we can do a separation in the security areas so that you still have some kind of safety guard, and then you can relax the safety requirements for your application. But it's a task for the industry to do so. I can't give you detailed explanation.
I know, yeah. Thank you.
Yeah, welcome.
I'm done. Yeah.
Other questions?
Further questions?
All right, if none, then thank you, Gerald, for that great presentation. Appreciate it.
Okay.
And we are on a break for the next 15 minutes, so please come back. Or actually, yeah, we're early. Wait here.
Are we early? Yeah, I said no, I'm exactly on time.
Yeah, you're exactly on time.
Yeah, that's what the TR1 is doing, even if the OEM is
we're
delayed.
extending your break. Go and meet somebody, okay?